In this topic, we'll unpack how a bank actually proves who a customer is in an eIDAS-compliant way and how it plugs external eID and remote identification services into its systems. We'll walk through the key components, the main integration patterns, and the end-to-end data flows that make the whole journey work. You've already defined the overall onboarding and signing journey. Now we zoom in on identity proofing, how the bank confirms who someone really is using eID schemes and remote identification. This is the foundation for qualified signatures and for the compliance evidence we'll use later in the lifecycle. Identity proofing is the moment we stop treating someone as just a device on the internet and start treating them as a known customer with a defined assurance level. It links the user journey to concrete KYC and eIDAS obligations, often via external eID schemes or remote ID providers. Those choices drive the architecture, which connectors and APIs you expose, how attributes are stored and reused, and how every step is logged for audit across the customer lifecycle. Levels of assurance are essentially risk tiers for identity proofing. For qualified electronic signatures, regulators expect the high tier, or an equivalent national level. That requirement narrows your options. If you need high, you'll typically rely on state eID schemes or tightly controlled video ID rather than a basic remote flow. You must also bind strong authentication to that identity and record exactly which process, provider, and evidence achieved the LoA for each KYC and signing event. Remote identity proofing is really a toolbox, not a single method. Banks typically mix three core patterns: live video checks, document plus selfie flows, and national eID logins. Each pattern is delivered by an external service and integrated through APIs. An orchestration layer decides which path to use, or in what sequence, based on risk, regulation, and context. Well-designed orchestration balances regulatory acceptance with user experience, device capabilities, and the chosen web or mobile channel. Video identification recreates a face-to-face ID check through a live video session. The customer shows their ID and face, while an agent or AI verifies that the document is genuine and that the face matches. All data, recordings, extracted attributes, and decisions flows through the video ID provider's API into the bank's onboarding system. This pattern is widely accepted for high assurance, but it depends heavily on staffing, scheduling, and network quality. In a document plus selfie flow, the user proves identity by scanning their ID and face with a camera instead of visiting a branch. The system reads secure zones on the document, checks for tampering, and then runs a liveness selfie to ensure it's a real, present person. The results are sent back into onboarding, typically with a risk score and a declared level of assurance that downstream systems can act on. National eID schemes let banks rely on government-issued digital identities instead of collecting documents themselves. The user is redirected to their national eID service, authenticates strongly there, and the bank receives verified attributes such as name and date of birth. This gives high assurance KYC and simplifies evidence handling, but its usefulness depends on how widely eIDs are deployed and whether customers actually use them. Modern banks rarely rely on a single proofing pattern. Instead, they run all options through an orchestration layer that reads risk signals in real time: device fingerprint, IP reputation, geolocation, document quality, and even user behavior. Low-risk customers might be approved with an eID or a simple document scan, while higher-risk cases are escalated to video or in-person checks. Throughout, the system captures evidence to satisfy both eIDAS assurance levels and AML or broader KYC obligations. You can think of the eIDAS node as a single doorway into all participating national eID schemes. The bank connects once, using standard protocols, to a domestic node or trusted gateway. From there, the node talks to other member states' nodes, translating protocols, validating trust lists, and normalizing attributes and levels of assurance. This lets your systems interpret a German, French, or Italian eID in a consistent way, greatly simplifying cross-border onboarding and compliance. In this pattern, the bank outsources identity proofing to the customer's home country eID scheme. The customer picks their country and eID, authenticates with that provider, and a verified attribute set is sent back through the eIDAS nodes. The bank receives core identity data and, in some schemes, extras like address or nationality. Two things matter most here. explicit customer consent on what's shared, and careful alignment of attributes, identifiers, and assurance levels with the bank's internal model. Every identity provider speaks its own data language. Attribute mapping is how the bank translates all of those into one canonical customer model. We take raw fields like given name, person identifier, and LoA, and map them into stable concepts such as legal name, national ID, and verification status. That involves normalizing formats, deciding which attributes are mandatory, defining fallbacks, and governing mapping rules so that any schema change doesn't silently break KYC or risk processes. Once identity attributes come back from an external provider, they pass through your orchestration into the KYC system and are stored with rich metadata: who supplied them, when, and with what level of assurance. From there, you deliberately split storage. Operational reference data goes into customer master systems so it can drive authentication, CRM, and signing. Evidential artifacts go into a secure audit vault with strict retention, minimization, and clear rules for reproofing when documents or details change. Resilient identity proofing assumes that things will go wrong. Cameras fail, documents are blurry, attributes don't match, or fraud engines flag risk. Good architecture classifies these outcomes and routes them. Low confidence but not clearly fraudulent cases move to manual review. High risk or technical failures trigger alternative methods, such as in-branch proofing. Throughout, clear error codes, correlation IDs, and user-friendly messaging keep investigations traceable while preserving a safe, accessible customer journey. You've now seen how remote identity proofing patterns, eIDAS gateways, and KYC storage work together. Solid attribute mapping and controlled data flows give banks compliant, auditable records while keeping flexibility in their channels and providers. In the next topic, we'll use this verified identity as the trust anchor for qualified electronic signatures and their associated evidence.